Right, we're going to make a start on this video. Someone's emailed me this morning. They said they've bought a Legionairre set off eBay. Are they any good? Well, it's a Harvard Good Boddy H403 with a different name on. And so's the Harvard CBM404. And so's the Alba CBM5, which looks the same as this. So the Legionairre, the Harvard Good Boddy and the Commando have the vertical meter, and these are well featured, and they were cheap at the price at the time, like $49.99. I remember them being, the Harvard Good Boddies being cleared for just £18.50. Now this actually has a mic to it. These aren't wired. I don't think these are wired like any other radio. Just printing off the instruction book, which at least we've got a photocopy of the instruction book, and at least there's a circuit diagram. I've covered this before. Harvard Good Boddy 8. So pin 1 is audio, pin 2 is common, pin 3 is transmit, pin 4 is receive. So if you look at the cybernet, move that across so we can actually see. If we look at the cybernet wiring, audio, earth, receive, transmit, it's audio and common, and then receive and transmit are transposed. Whereas on the Uniden, transmit and receive are transposed from cybernet, and common and audio are. So it's like cybernet, but with transmit and receive transposed. Of course, I don't know whether this is this the same? Harvard Alba CBM5. No, they've not mentioned that, other than Legionairre, and they mentioned Commando on here. No. So we'll find that out, won't we? It might needs a plug redoing, but it's a kind of mic we'd use. Power leads have been long unobtainable for these. If you're very, very careful, you can put a cybernet type one in. We've got a right one on the bench here, which is the Workman American replacement, which may fit. Sometimes they do, sometimes they don't. You've got to be careful. The sockets are easy to fracture. We've kind of got the right one, but is it the... Yeah, you can get the cybernet one to fit, but the trouble is you've lost your polarity, so we're going to have a look inside, or we'll look at this. So theoretically it's going to be positive to the left, so we'd have to make sure that that went in with the positive to the left, and you've got such a danger of getting that in wrong, but at least you can connect it. The cases have sharp edges, so be aware of that, and they're thinner than any other case I'm aware of, and they are vinyl covered steel with these insulators, and they are prone to rusting, and then the vinyl comes off. This one's been well looked after, to be honest. We've actually got a speaker on this. I've got two Harvard Good Boddies, but neither of them, I don't think either of them are complete enough to put together. One's got no, neither have got a case. One's a chassis and one's got the front. You never know, I'll end up with one sometime in a box of junk, and we'll be able to make up another Harvard Good Boddy. But I seem to recall they work alright when they're working, but they're not the most reliable sets in the world. And when I say that, I know they're 40 years old, but they weren't reliable when they were new. But some people swear by them, they love them. That speaker looked a bit iffy. So this one is one of the best looking innards I've seen. No rust. So this is the Harvard version. So I'll tell you what we'll do. Verify that positive is to this side. And look, the positive to the socket goes where we thought it did, to the left. So what we need to do is to scratch a positive on there. Now Mark's checked this at some point and he's said that it doesn't work by putting a red sticker on it. So I'll connect this to power. We don't know what it does, so we'll start off at 9 volts and current limited to 300 and something milliamps. Connect it up to the test equipment. And we'll switch on. Oh, it is on. Which is more than the power supply was. So we've come on and we're drawing 130 milliamps. So I'm happy to put this now on to 13.8 volts. Now current limited to 1.6 amps. So meter still lights up. So go into picture in picture and let's see if that's on the meter. No, it's not. Let's see whether this set transmits. Well, it does. And it's doing 2.8 watts. Transmitted audio. Voila. Is ridiculously high. Voila. It's 9 kilohertz, so it's transmitting on 3 channels at once. And let's see how on frequency it is. It's not far out at all. 2779108 should be 79125. I'm going to go for a lunch break shortly, and I'll wait. When we come back, we'll make sure by that time that the test instrument's warmed up, and we can start by adjusting that. And on receive, let's see if it's doing anything. I'll just set the signal generator. Right, let's see what happens now. Switch the cyanide meter on. Set these knobs right. So normal, CB, squelch down. Didn't like that. That sounds like duff capacitors in the amplifier, to be honest. That's probably what Mark didn't like about it. No, I've never changed any capacitors before. Don't think anybody's wanted to spend that kind of money. We've actually got no receive at all. So I've got the signal generator on full whack. and it's receiving absolutely zilch. Right, well, we'll have a look at the circuit diagram. I'll still tune up the transmit first, and I think we can start with that right now. The trouble is, can I see what the coil numbers are? Turn the volume down. So we're not going to touch the VCO, which is clearly going to be there. Obviously, we've no setup procedure for this. T7. T3. T4. T5, that's T10, that's on the receive, T6, and looking at how they are, they're probably a similar arrangement to the CBM404 in the way they get set up. It wouldn't be surprised me if those coils aren't interchangeable for CBM ones. So we'll start with the transmit, and let's see whether we can bring that up a bit. I'm going to have to unplug the extension speaker. It's one of those sets that plays that game. So it's 3.1 watts. Now, where have I put the expensive set of trimming tools? There we are. .1 still. 3.1. 3.1. So it's on full chat and it's 3.1. So there was no adjustment I made there that did anything to bring up the transmitter. Already at the maximum it will do. And that's not a problem. There's a lot of new sets which aren't any better in the RF output. Remember, I'm using a power meter here that's slightly selective. It's in bands. So it's only going to be looking at power within 24 to 32 megs. So it's not counting harmonics, whereas a normal power meter will count harmonics and you go, oh, that's doing good power, but some of it isn't on 27 megs. This is reading more or less what's on 27 megs. So my figures are often lower than what you'd get, but this is the truth, isn't it? The power on 27 megs. It's like telling you about a motor car, and if you drive around with the alternator not running, you'll do mega good economy, because that's taking about 700 700 something watts, isn't it? So I remember driving to Cheltenham, yeah, Cheltenham, 141 miles, and the alternator packed up shortly into the journey. It was a diesel car, and that car, it was a Peugeot, normally did 48 to the gallon, and on the way back that car did 68 to the gallon because it wasn't generating any electricity. So I've come to the conclusion that the RF meter is probably variable resistor 2. VR3 has been changed for a really high quality one. VR2 is there. So let's see on the front what it says. So it says it's a nice generous just over the 5 watts. Well, I know it sounds naughty, but we will always, I'm going to have to unplug this extension speaker again. We'll always we'll always set meters so they read 4 even if the set's only doing less than that. So I've now got that on spot on the line. It sounds disingenuous, but that's the best way to set them. Now I think low power's got an adjustment, so we'll go to low power, see what it's doing, and the answer is it's doing 280 milliwatts. Now it should be 300 milliwatts, then it's VR8 if we can find that. That's 5, 6, 1, 'Oh, where have you gone? Don't tell me I've got a version which doesn't have it after what I'm telling you all. See this one down here that's not labelled? It is. Just in the corner. I think this one's been changed at some time. It looks higher quality than what would have originally been in. So we've now got 400 milliwatts on low power. Back to normal. Let's deal with deviation. And I came to the conclusion it's VR5, but again I might be wrong. Let's get the little oscillator out. Key up. Oh, that's this kind of symmetry balance. I bet it's VR1 then. Well, it isn't. Well, we'll have to look into that off camera. Right, so I managed to get the deviation something like, it appears to be some kind of balance arrangement with the audio there and the deviation there. So what about receive? So I've dug out the Chinese cheapo signal generator because what are we not receiving? So this is generating 10.695. Nothing. So what about 455? I wonder if we've set this in one of the memories. Right, so that's 455. Ah. So it's receiving 455. So 10.695 is missing. So let's just put that back in. There's 10.695. That's what we've got missing. See if there's something obvious, something missing. So the 455 IF is in this area. There's the filter. So we know that bit's receiving. So where does 10.695 actually come from? It's usually derived from the synthesizer unless there's a separate crystal. Can I find the filter? You know, when you buy these sets, and this will be one we bought off eBay, doesn't mean they're complete, does it? But so I've just got to look for those kind of clues. This is strange because I can usually find the filters straight away. Well, I'm going to look at the circuit diagram and give myself some clues as to where it is. Yeah, quite frankly, I would expect it round there. Well, I'm going to be honest with you folks, I can't even find a filter for 10.695. So don't tell me it doesn't have a filter for 10.695, because that would be even worse than the Fidelity 1000, surely, for bleed over. So what I've done is the other thing. Here's the antenna connector from the test equipment. We've got the signal generator on full. We already know. Oh, hang on. So if I apply this round transformer 9, we've got a signal. Transformer 10, transformer 11. So we've either got a very duff transistor or it's not coupling. If those transistors there were short circuit, diode 7 and diode 8, they're there to protect the receiver from overload. In that case, we would have the signal shorted out if they were short circuit. So I think it's time to find diode 7 and diode 8 and just check whether they are duff. I can see 11 and 12, but then I would be able to, wouldn't I? This is the trouble when you've got no layout. So it should be somewhere like around transformer 9. There are, yes, I've got them, diode 7 and 8. So I'll turn the power off. If this is the case, it will be the first time in 40 years I've ever seen diodes fail in this part of the circuit. But look, I'm getting short circuit, aren't I? If you can actually see the meter. Got 0 across diode 8. Just turn the probes around for diode 7. Well, we better get those removed with that reading, because there's no other reason that I should have. Oh, I don't know. Because the coil goes to deck, it would also show as a short. I'm still going to have to take the diodes out to prove or disprove that theory. So I've got the radio switched off, and I'll see you in a bit. Right, folks, well, I took the shield plate off here so that I'll get to the underside of those diodes. Took them out, they read fine. I took out this capacitor. So there's the diodes. The aerial comes in via the filter, blocking capacitor. Took that out, and that was reading fine. It's difficult to read these in circuit because of other things. Ended up replacing that because it was so short on leads it was difficult to put back in, so I put a new one in. I did take that capacitor out and put it back in, took this transistor out and checked it. I wasn't getting the right voltages, but I was getting voltages here. And then I looked at the way it doesn't say it's RF gain, VR4, but it's RF gain. And this is the receive power rail. It goes to the centre, the wiper. It goes to one end of the potentiometer for the RF gain. The other end goes via 100 ohm resistors to chassis. And then the wiper goes to, well, resistor 32, which ultimately goes to the base of transistor 7, which is where I was concentrating my efforts. It was as if this wasn't powering in this area. And in getting my test prod in here, it suddenly burst into life. You won't believe what it turned out to be after all this technicality. Turn it the right way. It turned out that the yellow wire which goes to the wiper was pushed further down than it ought to be and was touching chassis. So it was shorting out the power rail. So hopefully when we turn it back on, we've got receive. Hey! So, now we can start on working on the receiver. So that is full belt off the signal generator. 100 microvolts, 30, 10, 3, 1. Excellent. The only coil I'd fiddled with is that. So we'll start by doing the detector. I can't see there's a 10.695 filter in this. I just think it's a coil and capacitor, which isn't good at all. But then we're not expecting that to be good, are we? So we'll go over to the oscilloscope. We'll put 100 microvolts on there. And according to my notes, I'm expecting T16 to be the detector. Yes, which is down there. So that's what I'd expect. So that was already set at maximum at the correct position. Incidentally, I just wonder what power we're still getting. I don't expect we've got any more. No. Right, we'll go with put the light back on. Go with the cyanide meter. And chances are the only adjustment needed is that. So that's got that back in. Trying to range about 4 dB on the cyanide meter, so we're not saturating the receiver. More signal on for that one. Just check that. Now, is there? I think there's a feed down from here to injection. I'll just check. No, it's not tunable unless L17 is it. We'll just fiddle with T17 and we'll always go back on transmit if I'm wrong. Just find T17. You'll be lucky. There's T17. No, it doesn't affect transmits, receive. So we'll just recheck transmit. And luckily I didn't upset that. So that's tuned. Let's see what we've got on. Let's see what we've got for 12 decibel cyanide. To be honest, it's good. 0.55. Yeah, 0.55 microvolts. So it's 3.2 watts, 0.55 microvolts for 12 dB cyanide. I wouldn't like it to, being a congested area, it's going to be a bit of a bleed over box without more filtration. Let's see if we can set some of these other things up. So we want S9 on the meter. It's actually bang on the S9, but I want to just prove which the setting is. So we need to just find, I think it's VR3, 6. Oh, it's the one which has been changed. Yeah, that's it. That's VR3. So that leaves us with Squelch. Now the Squelch is a bit wishy-washy on these. Could do with cleaning. Squelch, let's have a look. So I'll turn this control to full. Just a little stronger than I would like, and I think it's VR6. That's that one, isn't it? That's exactly where we want it. So we'll look at Squelch at the opposite end now. Let's go over to the attenuator and we'll turn the signal generator to standby, parking it at 0.3 of a microvolt. Now we'll set the Squelch to threshold. And switch the signal generator back on. Oh dear, that's dreadful. We'll have another go at that, because it's so dreadful. It may be slow reacting. So that's a carefully set threshold. Switch the signal generator back on. So it comes in at 3 microvolts. That isn't good, it's not sensitive. It's back off at 2.9 microvolts. There's not much hysteresis. But that is one of the letdowns of this chassis, and that's poor Squelch performance. However, it doesn't sit there hissing, and it doesn't hover. So we're all set up. So I'm going to just do a photo of this. So I'm pleased to get to the bottom of it. So it's clearly had some work done, but whether or not it wasn't, that was an attempt to fix it, or whether whatever's happened to it, you know, if that was, I suppose if it was dropped, it's possible that could just have migrated towards the chassis a bit more. So the two things to do, we just need to put some switch cleaner on the volume control, and there we are. So let's just see what happens if we plug public address in, see what happens. I once sold a broken one of these as a PA amplifier. Well, however Good Boddy that is. So switch to PA. 1, 2 testing. 1, 2. You have no control over the volume on PA. But at least you can have them both plugged in and it's not coming out of both. So that's clinched that. And then we'll just be tidying up the wiring on the microphone. Okay, so I've now applied the service cell switch cleaner to the volume control. So that's improved that. I'm going to put the bottom lid off. I'll take the power off to do that because You just don't know whether you go, oh, I need to put the shield plate back on. What a swine. I'll pause the video again while I do that. Okay, so that's a shield plate back on. So back where we were. We've got the insulator, we've got the bottom. And then we'll just set that frequency, put the power back on. Just from cold, it's doing 3.4 watts. It was 3.1 when it had been keyed up for 5 minutes with, with setting up the transmitter and that. So we'll just take the camera over to the frequency counter. Let's see where we are now. Oh, look at that, it's 27,79124. Well, if we needed to adjust it, it's there. We're not going to touch it because it's spot on. So with that, we'll smoulder the speaker back on. That's a bit like solder. I'm going to use the lower tag. Whoops, that was silly. I'm going to use for the negative, I'm going to use the that tag to put less strain on it. It's a bit weak. If we were the customers, I think we'd put some hot glue just on that to just support it. And just connect the negative. And Bob's your uncle. Does that speaker work? It does. Right, we'll pop that lid back on. And put the screws back in. Well, I'm surprised. I'm kind of half surprised it was repairable, because some of these are not. Right, I'll get these screws in and then we'll just flick round the channels and see whether there's anybody out there. Right, so we'll put it back together. One and a Roger. In a Roger. Well, there's no surprise there, is there, out here in the middle of nowhere. I need to dust that top off, don't I? Right, so we're all ready to do an on-the-air test. So that's what we will do later on this evening. So the Harvard CBM404 lives again. And as I say, this is the same chassis used in the Alba CBM5 and the Harvard Good Boddy. You mainly see it in the Harvard Good Boddy. So just have a look at this instruction book. This is a photocopy. This is a scan of a photocopy. So you've got the controls and there's quite a lot of pages to this, which is better than some. A bit on suppression, a bit on antenna mounting, especially if you've got an American car. So don't forget that it's this end which is the positive, right to the corner. Where's my pen? So it's this end which is the positive and that end that's negative. Well, ours is anyway. Bit about SWR and public address. Doesn't tell you can't do anything with the volume. Specification. It's supposed to be less than 0.5 of a microvolt for 10 decibels cyanide, but of course it isn't. But it's quite acceptable. It's better than some sets by a long way. It's supposed to do 4 watts. It's 3.4, isn't it? The best I can get, and it's 13.2, and I'm running it at 13.8. At least there was a circuit diagram, and that helps us fix it. So there we go. That's the Harvard Good Boddy, but in this case it's the CBM404 version, and these were about 1982. Thanks for watching.